Now we're going to connect up the circuit. We have the schematic, and the schematic consists of a voltage source that's at least 3.0 volts, and the load is 100 ohms. So this is what the circuit looks like on the breadboard. Notice that we have the resistor going in this direction as opposed to being connected from here in this direction. So this strip is all conductive, and so is this one. We have the circuit. What we want to do now is we want to make the measurement, and the most important thing, we know what the supply voltage is. That's coming from the battery. We know what the resistance is, and Ohm's law tells us that the current should be the voltage divided by the resistance. Okay, so let's check and see if we have 3 volts or greater, and we have 3.17. Okay, we're using, is that good? We're using the 20 volt scale, so we should be measuring like approximately 3.65 volts. Let's see. Okay, we've got 3.17 volts. Can you see that? Okay. So now we got the voltage. We know what the resistance is. We can measure the resistance, and it should be 100 ohms. So let's go to the scale over here, and now we're going to measure the resistance. Okay, let's see, we are on the resistance is 100 ohms. And we've got 112. We've got 112 ohms. Okay, so if we connect up the circuit to measure current, the meter has to be in series with the circuit. So we break the circuit. Normally the connector would go here and we'd have a complete circuit, but now we're going to connect the meter. We got to go for current, so that's over here, and we calculated that we should have approximately 30 milliamps of current. So we're on the 200 milliamp scale, and we should be able to measure by going from here and completing the circuit through the meter. Let's see, we can connect this part right here just to make it convenient. And we go there, and we get 30.2. So this is verification of Ohm's law, and we get 30.2 milliamps. This is the method that is used to do the engineering. First, you come up with a schematic that tells you how you're going to construct the circuit. Next, you do the calculations, which tells you how it's going to perform once you connect it up. And then we do the testing. We take out the meter. We want to measure current, so we connect the meter in series with the voltage line, and we measure the current, and since it agrees, we don't have to do any troubleshooting. Suppose it didn't measure the 30 milliamps, and we discovered that instead of 30 it was 15 milliamps. Then we'd have to check the resistance to see, did we put in the right resistor? But we've gone through the cycle. First, you have to have an electrical circuit. Secondly, you have to have the parameters as to which components you're going to use. Next, you have to do the calculations to see what results should you get. Then you take out the breadboard and connect up the circuit, and you take out the digital multimeter to measure to see whether or not it concurs with your calculations. This is the cycle.